Hey everyone, welcome to another Manufacturing Live. I'm Mike Buckley. With me today, I actually have a design manufacturing engineer, former colleague, peer, once upon a lifetime. Casey, introduce yourself. Who are you? Where are you from? What magic do you provide for everyone today?
How's it going, Mike? Yeah, my name's Casey Fischer. I've been in manufacturing for almost 20 plus years now, in some sort of capacity, and I live in Denver, and I have been married for about almost 12 years, and I just have a year and a half old. So things are interesting. So yeah.
Well, and contrary to popular belief, our backgrounds look the same. We're in different bunkers in different states.
Yeah.
So, if you want to talk about one thing in manufacturing is apparently basements are built the same in Colorado as they are in
Yeah.
Nebraska. So everybody can just be safe in that fact that we aren't just sitting next to each other in the basement. So,
Yeah.
um, so,
Got that nice faux cement brick,
yeah. Yeah, I could pour a slab and it could be a wall, but if I make it look like a brick, then it's more appealing to people. Um, Plus, I can charge more because it looks like a fake brick.
There you go.
So, um, hopefully, here pretty soon, I'll be in my actual new office in my new building. But we all have supply chain issues these days. But before we get started, before we dig into how you're managing new children, I have new children also, and in that world. I want everyone to make sure that they like or subscribe or put comments in. This is a live feed. We'll talk about it a little bit later, but Casey's contract at his current company is just coming up at the end. So he's actually looking for more opportunities around the planet. He's got some mad skills, but hit like, hit subscribe, join the community. Let's chat this up. Let's have a good discussion. So with that, let's start about, you said 20 years. So you got about the same amount of time that I got in this. You started in a sort of a hands-on type role, right? You used to build drift cars. I'm a gearhead guy. Let's talk about building drift cars because they're awesome to me.
Yeah. So yeah, I kind of started my career. I did some music for a while, and right out of high school. So when I started going, what was I going to do for work? I decided to go to the fabrication school down in Southern California. And it was just it was like maybe the first couple years they were open. But it was like the perfect spot to get your feet wet. You pretty much go in, they teach you how to weld and fabricate and stuff like that. Cut tubes, bend tubes. There's a lot of stuff. I remember they had like a whole night just on tape measures, and it was like, how are we going to do a whole night on tape measures, and then you leave and you're like, oh, I see now. Okay.
Yeah.
Yeah, no, I kind of started doing fabrication. I've worked in several race shops out in Southern California, doing road race. I spent a lot of time making CRXs, a lot of Honda Challenge stuff out in Southern California. And then I moved to building drift cars. Which is kind of my big passion. I really like drifting. It's super fun. But the idea is that you have to have, a lot of grip in the rear and a lot of steering angle and stuff, kind of lends itself to making new suspension arms and stuff like that. So, yeah, kind of cut my teeth out there doing that. And then, yeah.
You used to build roll cages too, right?
Yeah. That was like the big bread and butter was roll cages. I probably too many CRXs, I can tell you that. But yeah, the roll cage thing is they're super fun to build. It's more like every car kind of does. It's like you can build them all. I mean, now there's companies that just send you everything built and notched and cut and bent, and it's super nice. But back in the day when they didn't have a lot of that stuff, it was kind of more of a artistic kind of thing. So.
Well, and there's a lot of engineering that goes into all that stuff. You talk about control arms, you're changing steering geometry, you're building roll cages. You're gutting cars to get specific performance, not by OEM manufacturer specs, but to do a specific thing. So let's talk a little bit about the engineering of drifting, because I am fascinated by drift cars. I got to see yours in the early days when you were building it, and you came out to the shop a couple times with the one you had. So let's talk about what's the engineering component behind what makes a drift car different from other things.
So I think there's like a few things that drift cars like have to have. One, a locked up diff. You can do LSDs. A welded diff works great. Just when you're trying to get gas or make a U-turn, it makes a lot of noise, but that's kind of the fun part about it. And then for the suspension setup, like there's a lot of weight balance issues that go into a drift car, especially when you get to like the higher end stuff. You don't have to do this kind of stuff when you're wanting to just take your beamer out, or you can just weld up a diff, get a seat, and go. There's a lot of nuances to the car and stuff like that with the rear grip, and then just weight balance and stuff, and then of course the steering angle. Getting to where you can actually, throw the car and try to even go backwards into corners and stuff like that. So getting into the 60, 70 degrees of steering angle is usually sometimes pretty difficult on some cars. But other cars like, BMWs or what's a couple other ones, Nissans. And at this point, almost everybody makes like drift angles kits for stuff. So it's like if you have a Corvette, which are like super popular now, just because they're like C5s are so cheap, you grab one of those, put some knuckles on it, and go. That's pretty much, it's almost like a competition car at that point, so. And then working with roll cages, I mean, if there's always like a spec. So if you're doing SCCA or NASA, they have like a spec for that, and then FD has their own stuff with Formula Drift. They have their own specs for doing cages and stuff, and it's mostly just keeping the driver safe. So.
Yep. They do. Which one is it? Do they all do the ultrasonic testing on the welds and everything else when you get them certified?
No, it hasn't gotten that in depth. I think mostly it's like a visual pass. A lot of tracks now, it's like you can just pretty much go out and go drifting. There's not a lot of tech inspections, which is kind of wild to me. I mean, it's kind of one of those things where this is why you want to do due diligence when you're building a car and you want to have like an actual safe car to build. Getting a Harbor Freight welder and buying some tubes isn't the best way to go on some of that stuff, but at the same time, sometimes you got to get it done and send it,
Yeah. Hey, I have done lots of sketchy stuff in the past in cars, and when I was in college, I had a locker in my Cutlass.
Nice.
And I drove that every day, everywhere.
Yeah.
So I can respect the slow turning on the corners with the chirping and everybody getting mad because you're the idiot.
Yeah.
Driving around town with a locker. Yeah. It was a lot of fun though, so I can respect that. So drifting is a lot of controlled chaos from the outside, right?
Yeah.
Like you're trying to control the power, you're controlling the skid, you're getting the turn to be able to power through a curve, not just slide around it like the Dukes of Hazzard out on a gravel road, right?
Yeah, there is that like I was kind of talking about the rear grip. That's almost one of the biggest things you want in a drift car, which sounds completely backwards. You think you want really stiff suspension and you want to just be able to throw it in, but the idea is you would drive into a corner and throw it sideways, and once you get that rear grip kind of behind you, it ends up slowing the car down into a corner, and then once you get on the gas, it actually propels you through it, so you can actually grip up and get out. So it's one of those things where it sounds a little backwards, but it's a little weird too, because you also have to deal with the power to like a power to grip ratio on your car. So if you only have like 100 horsepower, which is usually the cars that I have, they're pretty cheap, and kind of once they're done, they're done. Having a little bit of horsepower, you have to kind of balance that grip. You don't want to throw a ton of grip in, because then you're not even gonna get sideways, So yeah.
You don't want the Mad Max blower car out drifting.
No. Yeah. Even though that'd be kind of cool, though.
I mean, the blower spool and the sound is amazing, but probably not the best fit for a drift car. Yeah. So you mentioned the cars, when they're done, they're done. That gets into a little bit of recycling, which is where we met. Gosh, what, 8 or 9 years ago now?
It's been a bit,
that long.
When me and the wife moved out to Denver, I remember coming out here and looking for work, and that's where we met. And then we got to work for a while at Carl Schmidt doing recycling conveyors and stuff like that, which was actually really fun. May not sound so much fun on paper, but I had a blast. It was actually some of the best CAD work I've done in a while.
Yeah. So and let's talk about a little bit of that journey, because when you first came in, it was more on the welding side, and then very quickly you started learning, some of the engineering tools, engineering software. So let's talk a little bit about that process that you went through, because I think this leads into a good discussion of engineers come from everywhere, because you just talked about a whole bunch of things, from drifting and building chassis and roll cages. That is pure engineering and understanding of how things move. We get into Carl Schmidt. You started on the welding side of things, and then let's talk a little bit about that journey, because that really propelled what the next steps of where you're sitting today in the Colorado bunker.
Yeah. So yeah, I mean, like you're talking about, like before CAD was, cardboard aided design, you know what I mean? Like, you don't really have anything like that. But like I was saying, we came out to Denver and I started working at Carl Schmidt, and I just remember doing the fabrication and stuff and welding and doing that. And then I remember one day coming up to you and just being like, hey, like, I'd like to learn more. And I keep seeing, Solidworks up there. I've seen it, before at a couple of my other places I worked at. And it was just like, it seemed like that was the next step for me, was to, take the knowledge I've learned from, just being hands-on and doing things. I almost prided myself on old schoolness, you know what I mean? Like being able to do things like, very, very consistently and kind of like not have to have the reliability of a computer or CAD and stuff like that. But I feel like that's one of the biggest points that really, really helps, is that if you have like a good amount of knowledge and you can use CAD, then it's like a no-brainer. It's that's where really all the doors started to unlock and stuff like that. But I remember coming to you and just saying like, hey, what can I do? Like what do you do? You know what I mean? Like what does that look like?
The question of what do I do? Nobody knows what that is, but
I'm hoping sometime to figure it out, but I don't know if we're gonna get there.
That's probably another episode by itself. What is it that Mike does? So I do want to, before we go to the next step here of talking about KWS, you mentioned something about the engineers being able to know how to fabricate. And that was one thing that we did at Carl Schmidt a lot, is we had the engineers come out and help build when we were in a rush. We had engineers come out and help work with that process. Yeah. And that led to what we'll talk about a little bit later with Dana and everybody else, that lifelong bond of coolness that you guys have. So when you started doing SolidWorks, I think it's important for everyone to understand too, is like one of the things we had at Carl Schmidt is if someone wanted to learn SolidWorks, want to learn engineering, it was open for everyone. The key was we worked early in the morning in the shop, so we opened up the afternoons for anyone to come in and do that. So a lot of your SolidWorks,
after you do a full day, 8 hours, full day. Try to stay,
Yep. So a lot of your learning and process, I do want to be clear, it was your own initiative to want to be better. And you would come in after welding, assembly, fabricating, working in the shop. You would come in the afternoons and then work in engineering. Yeah,
stinking to high heaven and working in the engineering room. Yeah, that was me.
Yeah, with our 1,000-pound tread plate tables.
The overbuilt desks. Yeah, I remember that one.
And we could talk about that in a little bit. But so you started learning all of that on your own with the company components.
Yeah, because you kind of opened up the door and was like, here's the get started books. Get at it. And then you kind of go down the path. Everybody makes that first little part that's in the book, and you know what I mean. And then you just go from there, and it snowballs. But I don't know if it's just like years of video games and stuff, but it just felt really comfortable. You know what I mean, getting into that, and it was definitely something that like instantly I was like, this is rad. Like I like this, and being able to get, for a long time, if I had an idea, I had to either draw it, which I'm not an artist, so that never worked out, or build it. You know what I mean? Like you had to actually go and do something. And now it's like you can do so much with CAD, and then also just with simulation and all the other stuff. I mean, we were watching like this thing on like an architect way back in the day where they had to, they were doing like pillars and columns and stuff for this building. And it's like, they had to literally stress test that in the parking lot before they were, before they built everything. And it's like, that just doesn't happen anymore, which is, it's nice. You know what I mean? Like you can cut out so much of the fat, if you want, of manufacturing with a lot of that. So, but yeah, it was definitely something I got hooked on real quick. So, yeah.
And before I ask you the next question, just a reminder, this is live. Please jump in with any questions you have for Casey, because we're gonna expand upon recycling here in a little bit. But it's important to understand the journey that Casey took, because he has a lot of raw talent, a lot of engineering, manufacturing knowledge, and this is sort of the journey he took to get where he's at today. And there's some really cool things that we'll talk about here in a little bit with airplanes. But once you learn the SolidWorks component, at the same time we were going through automation changes, right? So we put in some lasers, we put in some CNC brakes, and that sort of led your next transition over into programming from the SolidWorks stuff. So you want to talk a little bit about what that journey was like, going from welding and fabrication to SolidWorks and then over to running CNC equipment?
Yeah, so it's one of those things. I mean, I think a lot of people can relate. Like, just opportunities open up, things happen, people quit, and there's usually sometimes there's an opportunity for you to stand in the gap. And some people shy away from it, but I think there's a big learning curve that you can grab onto there, like where if someone takes off and we need someone to fill this position, it's like, well, I can probably help with that, But I was doing the welding and fabrication there, and then I started doing the engineering, which was, I mean, it sounds like a quick thing now, but it was months, you know what I mean, of going in after work or on Saturdays and stuff, just trying to get this stuff done, and get to a point where I just felt more comfortable with it. And then we had some personnel loss, and I was able to kind of jump into the laser operator position, which was something I was not thinking of or really had on the radar and stuff. But that was like kind of the what do you want to say, the gateway drug into CNC was probably the the laser. It's like one of the easier things to program, as long as your setup is good on the machine and stuff. But and working with you there, it's like there was a lot of processes that were set up for me to be successful at that. Like there was, we had CamWorks at that point, and that's now different things and stuff like that. But we had a lot of tools that really just made it like, you just take this and throw it in there and it's done, that's a lot of work on the back end, which a lot of people, I don't think, really get to see a lot of that.
We were we were very process heavy in the changes that we made, right? Even in the engineering side, we were doing things with SolidWorks that not a lot of people do.
Multi-body stuff was that was the big thing. I think even looking back, multi-body was probably the biggest thing I learned there, and just how easy that was.
Yeah, and we added a few other things at that time also. The 3D Experience Works platform came out. We had some of that. We had simulation. We had CamWorks, NestingWorks, SolidWorks. We had the whole plethora of technology there that we were trying to leverage. So before we jump to the next step, we did ask out in the chat world, how they got started with CAD. We had Samuel come back and say that they learned it through First Robotics. And then there was another one through University Trike Motorcycle Project from, I'm horrible at pronouncing names, Alvaro. So I apologize if I have mispronounced that. Keep coming with those things. Myself, you mentioned the getting into lasers and learning it that way through opportunity. That's actually how I started with CNC as well. I was a manufacturing engineer. I was doing design. I was working at Benson Machine Works at that point in time. They just put in a laser that was very similar to the one that we put in at Carl Schmidt, believe it or not. The laser from Carl Schmidt, we actually bought from Benson Machine Works.
And it was what year was it? I mean, it was DOS, you know what I mean? Like it was a 90s. Yeah, it was a 90-some 2,500 watt Trump with a Bosch control. So it was before they went to Siemens. I've always been a fan of the Bosch control because there's unlimited capability that you can do with that machine. Yeah, it's almost too stupid to know what you're doing.
Yeah. Yeah, I mean, like we were cutting tube legs and things like that in a laser that was designed for flat sheet, right? So Dan one day was like, hey, we got an option for someone to learn how to program the lasers. And like I was like, I'm dumb enough to try that. I raised my hand, and that got me into this whole CNC thing, which sort of led to where I'm at today, running. Because then when I got into doing aerospace parts and things like that, running other machine shops, that knowledge that I learned from just raising my hand really got me to there. So I started out more on the manufacturing engineering side with a real strong emphasis on CAD, but then through raising your hand, like you go completely on a different tangent, right?
Well, I think too, it's like, raising your hand like that, it almost makes it easier for you to make mistakes. You know what I mean? Like it's okay to let, you don't know what you're doing. So why would you, not know that, So it's like, I think it makes it for a better, like kind of apprenticeship kind of thing when you do something like that.
You remember those big vacuum odor containers that we built?
Yes. Yeah.
Yeah, those great big monster things that would they would fill with that material, and then it would get rid of the odor of gases, right?
Yeah.
And you talk about that from a design, and we got some feedback here we'll go through in a little bit, but you talk about that from a design, and I think back to those, like between like Dana and you and a few other people, we made some really cool, beautiful looking tanks, right?
Yeah.
And understanding the manufacturing process and everyone collaborating together. You remember how big those doors were, right? Those doors were like what, 6 foot by 6 foot?
Yeah. I mean, the only way you deal with that is with overhead cranes. You know what I mean? Like that, like there's no lifting that,
Yeah. But when we were done, the way that you and Dana had designed those hinges, one person could walk up and push that thing shut and vacuum seal it tight.
Yeah.
Like that was all part of that process of, we use technology, we use software, and we used a collaboration of understanding manufacturing, your input on how to weld those things, how do we put them together? How do we fabricate those? Really made something that was, in my opinion, probably one of the more beautiful designs that we did in our team there.
Well, there was, I think back, there was even just the straight recycling conveyors were, at a certain point, you start taking a lot of pride in how they look, you know what I mean? Like, and stuff like that. And it's just, I mean, I always think of the Revolution, you know what I mean? Like that was
kind of the Revolution.
Yeah. The circular sorting station. Like that was a huge project. I mean, and engineering very, very heavily engineered. Like, I mean, it was how high was it and how wide was it?
Like it was, and you were going back 8 years plus now, but it was over 12 foot tall because each bin had its own compactor around it. So we had 12 stations. The material went up to the center, and then it had a rotating table, and that rotating table would have people stand there and sort.
Yeah,
and as you dropped it in the bin, it would go to its own compactor. And the idea was, instead of a linear facility that takes a lot of space, this would sit in a smaller area. It could be used like Goodwill for sorting clothes or anything else. But at the end of the day,
running on that one too.
Yeah. It would you could auto sort it, but it was a very small, compact system. But I think it was, if I remember right, the first one we did was like 12 foot tall, so the compactor could fit underneath of it. Yeah. And then the diameter of that thing was 20 feet overall in diameter.
Yeah. But the other thing, it had to be on a truck. That was like the big thing, is it had to be disassembled. It had to be able to be moved on a truck. Like
it fit on one truck.
Was it one truck?
I'm pretty sure it was one truck that we put that whole thing on. Because
now it's like, just get another truck.
Yeah. Well, like when we did that project in the Bronx, we sent 56 semis to the Bronx full of material, full of equipment for that recycling system. So this was, if I remember right, I think it was everything had to break down, bolt together, sit on one semi, and then be able to put up very easily, very quickly, and then have adjustments for different type of horizontal. I don't think we did vertical stroke balers. We did horizontal balers.
Okay.
In that, if I remember right, but let's talk. We got a few more questions or a few more comments here. Let's jump into those, and then we'll jump past the Revolution into the other things that you've done here. So Jameson commented, after learning SolidWorks, did you immediately pursue getting a SolidWorks certification, or did you focus on improving your design skills?
Yeah, very good. No, cert right away. Like that seriously, if there's anybody listening right now, like, if you can, the cert was just such a door opener. It's like, you learn stuff from the get started stuff, and you kind of, mess around with your own designs and stuff like that. But getting the certification was probably the biggest thing, because then it like pretty much what the certification is for, it tells everyone you're at this level. And I think that's one of the biggest things that SolidWorks offer is the cert program, because it really, it's such a job maker. You know what I mean? Like if you can
Yep.
get those certs and just keep learning and stuff. And then of course, like that's, you kind of opened up the door to, we did presentations at SolidWorks World. And the cool part about doing presentations is you get to take certs for free. So like we'd go there and just like bang out as many certs as we could in that, you know, I think you got like 2 hours, you know, and we're just, yeah, you know, trying to go. But yeah, for sure. Get the certs are well worth it. So,
Well, and you bring up a good point, because call for papers are open for 3D Experience World this year.
yeah.
And Casey and Dana are both going to be submitting, more than likely presenting, because you guys have done it for a number of years now.
I think it's like
You guys
5
have
or
had
6 years now. Yeah.
Yeah. You guys
It's a
have had
fun
really
time too. Yeah, it's a really good time. Like, it's like Comic-Con but more nerdy, you know?
well, and the topics that you and Dana talk about are how do we design and manufacture more effectively, right? So it's a very much an extension of this. So if you are wanting to get certifications, 3D Experience World is a good place to do it. And more importantly, we're always looking for people to present on a wide array of topics. So for that, I believe, if you just type in 3D Experience World 2023, there's a website with a call for papers. Ian, who's helping on the back end, I'm sure he'll put a link in the chat for people to go sign up and register. But please do, because, you know, one of my favorite times of the year is going and chatting with people like Dana and Casey and getting feedback and understanding, you know, how do we make the product better? Where are we going to go?
Yeah. And there's so many cool people I think you meet at those things, because you're so like-minded, you know what I mean? And you're really looking at like the cutting edge stuff and how do you implement these things into the workflows. And yeah, it's a good time. Yeah.
Yep. Well, and there's a pretty good group of people too. Like I think last time we were in person was in Nashville. We're going to be back in Nashville this year.
Yeah, that was nice.
You know, I had a picture pop up the other day from like the folks from CAD, Center for Advanced Design, that did the lid boss, and you and me and Dana and a few other people, like all out chatting, having a good time. So it's a great networking event on top of that.
Yeah.
So there's another question that comes up, but I'm gonna let you answer this one. Because my opinion doesn't matter in this one. Casey has his own seat at SolidWorks, and he does contract work on the side for people also. So you get to answer this question.
All right.
Is there a place to sell 3D CAD parts or designs?
I think you can always, you know, the most of the contract work you'll get is someone will probably have something, you know what I mean? Like they'll have an idea, or a lot of it is more, I need drawings. You know what I mean? Like I have like some CAD stuff I've kind of put together, but I need drawings, you know, or I have this thing I've made, I need you to make it in CAD and then put in the drawings. Like that's usually where that kind of stuff is. But you know, I know with 3D printing now, like you can get on CAD, you can make up some designs and stuff, and you can sell them. You know, there's a lot of stuff on even like Etsy, stuff like that. There's definitely a lot of uses for CAD when you have something like that. And then as soon as you have your own seat, it's one of those things where it's like you instantly, if you play it right, it's a really good moneymaker, you know?
Yep. Well, and to be fair, like we talked about the odor boxes, we talked about the Revolution. Those were all contract things we did for other people with ideas.
Yeah.
They had an idea. We did the engineering work as contract when we were at Carl Schmidt. And then we ultimately built that based off of our designs with their approval. So, you know, imagine that, but in a scope of you doing it yourself versus through a company like us where we were doing
and that seems to be pretty standard with a lot of manufacturing companies and stuff. Like they'll just, you know, you'll get someone that walks in the door and they have some wild idea, and sometimes it turns out to be great. Sometimes not so much, but you know, like
we had a couple of those.
Swing and a miss. It happens.
Yeah. So the last question we have, or the last comment we have right now, and then we'll get into the next part of your journey is, Judy posted, like Casey, I love to draw, but I'm not an artist. Learn manufacturing from working with our model shops and then working with prototypes. That's a pretty good path that we see a lot of people go on. Chris McBain was on a couple months ago. He started as a pattern maker and then got into this side of the fence.
Nice.
And I think it's very comparable to like the journey that you were on, the journey that I've sort of been on. Mine's a little more wild because nobody knows what it is I do. But so, you know, we were all together at Carl Schmidt, and then, you know, as luck would have it, Carl retired. We all sort of moved on and did our
Yeah.
own things.
Yeah.
After that, you went into full-time manufacturing engineering. So let's talk a little bit about that process and what that evolution was. So you went from shop and building and engineering in the real world as you were doing it to design, CNC programming, and then you moved over to a company and did full manufacturing engineering. So what pieces did you learn along that journey?
Yeah, like so I, starting at Carl Schmidt and doing the fabrication, then when I left Carl Schmidt, I was pretty much doing full-time engineering stuff. They, got a replacement for me out in the shop, and I was just doing that. And I feel like that was like the real, you know what I mean? Like, I feel comfortable with this, you know what I mean? Like, and at that time, Carl Schmidt was kind of going through some changes and stuff, and a lot of us left at that point. And I moved over to Weiser Engineering out in Arvada. It's a super nice sheet metal job shop. They do welding, fabrication, hardware, but it's mostly sheet metal, and a lot of lighting and stuff like that. But moved over to Weiser, and I think the best thing that I got to work there, other than like the people, you know what I mean? Like, moving from job to job, you always meet awesome people. But they went through parts there. Like, it was millions of parts, like from little tiny things to, big sheets and all kinds of stuff. But I think the biggest thing that I learned there was I got to just see prints and CAD, like, from other people. It wasn't something that we made or we talked about. It's this got dumped on my desk. We need to make it and figure it out, And I think going through and looking at prints and looking at how people did that, and what was wrong and what was right. And then also with CAD, like, I don't know how many times I tried to unfold something that someone would send me, and it's like, no, it's not going to do it. Or it's like I don't know, like there's so many bad ways to do sheet metal. But yeah, that was kind of the big thing, is I just got to sit there and just go through so many parts. And then also with the welding and fabrication stuff, I got to do a lot of welding fixtures for the shop, like, kind of knowing how that process goes. Like, I can, hopefully design a welding fixture that would make it easier and consistent and stuff. I will say I've made welding fixtures once you welded it, it didn't come out of the fixture. So there's always learning curves there.
What do you mean? It works on CAD. You just use the move button, the robot, and it just moves.
Yeah.
You don't have to worry about whether that bar overhangs and you can't pull it. There's no such thing as shrinkage or movement or anything else. It just magically works, Casey. I don't know.
Yeah. But yeah, I have had to cut a welding fixture off apart. So yeah.
Well, and I think you and I, we used to have old man breakfasts, you, me, and Dana, when we all lived in the same area. And one of the things that I always thought was cool that you talked about is when we were doing stuff at Carl Schmidt, we were doing recycling systems the size of football fields.
Right.
So our tolerances were a bigger gap, right? Like, we laser cut and tabbed everything and put everything together to make them within a certain spec, which was different.
If you were hitting an eighth, it was great. All day.
But at Weiser, you're down to thousandths of an inch.
Yeah. That was something that Weiser really did well, was they really had a good group of sheet metal guys. And they, with sheet metal, holding 30 thou on stuff is pretty difficult, Yep. And I worked with guys where we held 5 on stuff on some of these metal containers and stuff. There was, just the tolerancing that we tried to hit at that place was really, really high or low. But but that's kind of the thing, is like, you go tolerancing is what you need. You know what I mean? It's not like everything doesn't just, you don't just put 5,000 on everything. You know what I mean? Like, it depends on what you need. If you don't need the tolerance, you don't need it, but yeah.
My favorite or profile tolerance is a +or-5 on a part when it's in the flat pattern before you bend it.
Yep. Yeah. Yeah. Don't ever dimension the flat pattern. Yeah.
One of my other good buddies and former colleagues, Brian, posted, "I firmly believe having designers and engineers visit the shop often to see how manufacturing group does things can make you a much better engineer."
Yeah.
And
yeah.
I couldn't agree with that more. I think the wall scenario that happens hurts companies more than it helps.
Well, at future companies, yeah, that was something that was dealt with. But I think also too, like having that openness and the communication is huge. You know, like at Carl Schmidt, like it was a door that we had to go through to get to the engineering department if we were on the fab floor. You know what I mean? And then at Weiser, like, you know, I'd get guys yelling at me all day about, you know, how I made this print wrong and, you know, you got to get, you know, but having that, you know, having that communication and even just hanging out, you know what I mean? Like you learn so much from these dudes that have been doing it for their whole life. You know what I mean? Like, and for them it's not a big deal, but for me it was like that's just huge information to grab, you know, if they're willing to give it up.
Yeah. Well, and I think it's part of the problem. We've talked about this before in other live streams, is humans suck at communicating. We just do that. It's a problem, right?
Yeah.
And then we couple it by the traditional things that happen in manufacturing where, you know, you mentioned there is that us versus them mentality. And then you also think about the fact that engineering is traditionally more introverted people. So we already are horrible at communicating. Engineers are more introverted. People in the shop they're a little more loose with the verbiage, right?
Yeah. Yeah. I mean, it was two different work environments. You know what I mean? Like engineering is traditionally in an office space, you know what I mean? With air conditioning and, you know, heat and stuff like that. And the manufacturing floor is usually not, you know what I mean? Like it's usually cold and hot and, you know, you get things thrown at you and whatnot, you know?
Yeah. I don't know what you're talking about. There was never hard hats thrown at all when we were at Carl Schmidt. But I think you take that and it's easy for people just to keep them separate. Mm-hmm. And if you're only interacting when there's problems that arise, you create a deeper divide, right?
Yep.
And then sometimes people are seen as being jerks or a-holes or anything else like that. And it's not a matter of that they are that as a human. It's a matter of we're not communicating at the same level.
Well,
right?
that and you know, manufacturing is traditionally at the end of the process. You know what I mean? So there's the time frames are tighter. You know what I mean? Like the supply chain stuff is very, you know, demanding. Like as soon as the part comes in, we got to get on it, you know? So I think that's another issue too, is that, you know, with engineering, there does sometimes feel like where there's like, oh, they got, you know, weeks to work on this. Now I have 3 days, you know? And I think that's something that'll add to that too.
Yeah, I think it does. And, you know, then you have like, the shipping people come down on you and the payroll people come down on you, right? And you're the people in manufacturing that are holding it up, and they're not looking at everything that happened before to make it late. And a lot of the reason things are late is generally because of poor process or poor communication.
Yeah.
You know, not every company has people from engineering out help shuttling paint carts to make the truck go, right? People aren't out holding fixtures that they just designed to help welding get in that methodology. It's a unique company that gets into those roles, but I think the challenge we have in general is we don't communicate well, and then it's easier for us to put up walls to not communicate and then just go run to someone else and be like, they're being a meanie, they're not talking to me, they're not making this work, my feelings are hurt, versus just being like, hey, let's just have a discussion. Let's get through this. We all get the same paycheck. It's all coming from the same company. We have to succeed as a team.
Well, you're all on the same team at that point. You know what I mean? Yeah. Like you want to be successful as an engineer. You want to see your design, you know, and you know you want to see it come to life. And I think also too, it really depends on the actual engineer and maybe not even the company, because there's some engineers that they just can't, you know what I mean? They have to be down there. They have to be, you know, and I think that those are some of the really, you know, the unicorn engineers where it's just, they're just so, they have such a plethora of knowledge that they've learned from so many mistakes and, you know, like stuff like, you know, that's how you learn, you know, like, and I think, you know, being in the, you know, shoulder to shoulder with the manufacturing floor and having that relationship, I think that's I would almost say that's the biggest job description of a manufacturing engineer, is to bridge the gap from a shop floor to a design engineer, where that's really your job. There's a ton of other things you do, but really what you want to do is you want to get their design into their hand and have it go, you know what I mean? Like, and try and get all that stuff out of the way, you know?
Which, I mean, that's a lot of, from, again, our old man breakfasts, that's a lot of, it seemed like what you did at Weiser.
Yeah, yeah.
Was you were the conduit from office to the facility to make sure you're making parts within spec, on time, on budget, to make the customers happy.
Yeah, yeah.
A lot more than that, obviously, because you had to fix a lot of things. But like in a general sense, that was.
Yeah. Well, I mean, like running a first run part. I mean, you have to take time with it. You know what I mean? Like you have to get it dialed right. You need to. Oh, hey, we didn't know we needed a fixture. Now we do. Or this thing's not bending right. Like why? What can we use to do that kind of stuff? And then of course, like Weiser had a big machining department, so it was like getting into ops and what we can do to shorten times and running overnight and stuff like that. I mean, it's interesting problems to solve. I think that's the fun part I like.
Yeah, I agree with that, and that's always been the part that I've enjoyed about this process, which is probably why I'm still around after all these years doing this similar type stuff. Right? Is there's always a new challenge, there's always new people, there's always something on the horizon to do better or different.
And there's so much information coming out now, and things are changing rapidly. You know what I mean?
Yeah.
Especially with the where we're at with manufacturing, just in general in the United States, like it's heading for a different vibe. You know what I mean? Like it's going to be different.
Yeah.
But I think it's gonna be great. You know what I mean? Like I think a lot of stuff is going to start bringing more in house, and but then that brings a whole lot of problems too.
Yeah, I saw an article last night that there's a big push for bringing stuff back in country here. I think it's happening everywhere, right?
Yeah.
But they're trying to bring things back to the country that they're in. It was a CNN article. I sort of skimmed it. I didn't get a chance to read it all in depth, but it really sort of reiterated what you just said, is the manufacturing companies for tomorrow are going to have a different thing. And I'm old. Let's just face it. I relate it to when I first got into the CAD side of the fence, right? There was such a thing as you had a design engineer, then you had a draftsman. The design engineer came up with all the ideas, made sure that it was going to work on a fundamental science level. Yeah. And then the draftsman was the intermediate that created the prints based on what the engineer thought.
Which is wild to think that prints were like with pen and paper. Like it blows my mind still, like thinking about that.
But a complete separate group of people, right?
Yeah.
And then the draftsman was the one that was accountable for making sure is my tolerance is right or my GD&T right. How does that work, right? And then there's this parametric CAD revolution that came along, and that sort of truncated to where a lot of draftsmen had the skills of a design engineer, maybe not have the degree, but they were now able to shorten that cycle. So you had draftsmen become designers, you had designers become draftsmen. It sort of melded it together to where you rarely see now in a lot of mainstream companies where I have a design engineer, he's just sitting over here thinking shit up, and then I have the draftsman that's doing that, and then it gets past the manufacturing engineer. Now I have designer, manufacturing engineer, floor. And I think in the manufacturing world of the future, I think you're going to see even another shift to where that gets truncated further. Less of a wall, more of a collaboration environment. And I think we'll all succeed from that.
Yeah.
But
there's just so many, the tools that you have in your tool chest, or whatever you want to call it, like they're just so widely available to everybody. You know what I mean? Like, one of my big things is like, I would not be here if it wasn't for people to like take time and teach me things. You know what I mean? And that's something that I always like to do is teach people as much as I can about what I do, and show them the tools that I use to do these things. And a lot of people end up like, just taking off and starting doing those things, or, at other shops I've had where, a guy on the floor was just really like, I want to learn SolidWorks. And it's like, sweet. Like I know how to do that. Like, and being able to teach that is awesome, but I think there's a point where it's really going to be, fewer handoffs, I think is probably the biggest thing, that information loss that you can get from going from person to person to person to person, and just keeping that, kind of in there, and especially with the way that a lot of that stuff is, it's all held in that part, so, or the file, if you want to say.
Yeah, it fits a lot of that single source of truth, right?
Yeah.
And by having more people in the discussion, the communication gets a little bit better.
Yeah.
Which again, as humans, we suck at communicating. And I'm sure there's emojis in this stream right now. thumbs up, thumbs down. We hope that thumbs up means thumbs up in 25 years. Thumbs up may mean something else to the next generation, right? It's like hieroglyphics on the cave wall.
Well, it's like the fact that, like, yeah, I'm gonna date myself here, but hashtag, that was the pound sign. You know what I mean? Like,
yeah. I remember 100 meg zip drives that were the save icon now. You know, things you never had to worry about. After Weiser, though, you got into a little bit of airplane manufacturing. So let's talk about that a little bit.
Yeah. So at Weiser, I was at Weiser, and I saw. So actually, I go back a little bit. It was at Solidworks World. I couldn't tell you which one. I think it was probably 18 or 19. But
yeah, probably right there.
Yeah, Boom Supersonic came and they did a presentation on their plans, you know, for building a prototype and you know, changing passenger airplanes to supersonic. And it was something I was really into when I remember seeing it. And I was like, that's rad. Like, why is no one doing this? You know? And I remember at the end, the guy who gave the presentation was saying, like, we're looking for people we want to hire, you know, and I was like, okay, all right, you know. And then I was looking through one day on Indeed and I saw Boom Supersonic, and I was like, oh, okay, all right. So I threw my name into the hat on that one, and then got interviews and ended up working at Boom for 3 years. Yeah, 3 years. But I was a manufacturing engineer over there, which was at that time with building XB1. Was that manufacturing engineer at Boom Supersonic is probably one of the most demanding positions, I would say, in that company. The manufacturing floor was definitely on a different level, which I really enjoyed, you know. But after Weiser, I went to Boom, and
And from there, you know, some of the things that we talked about is you got to work with a bigger network of manufacturers from all over the country, right?
Yeah.
That was like you were down to the company on.
Yeah, I mean, communication is key. You know what I mean? Like, one of the guys I used to work with at Boom, like, his thing was over communicating, and it's one of those things where it can come off as annoying sometimes. But if you're always on it and you're always talking about things don't get left through the cracks. You know. But I think having a relationship with your vendors, you know what I mean? Like, and I think, you know, at that point, when we have so many vendors and you have so many parts out and the time frame is so crucial, we would have weekly or even like 2 times a week meetings with vendors, just to talk about how things are going. Like, do you need any help? Do you need anything? What's the process on this? You know, how far are we on these parts? And I think like you're saying, the communication is crutch. You know what I mean? So.
Yep. And, you know, as we talk about this, you know, like with Boom, you had a contract for a set period of time. Then after that, you've been doing some Wi-Fi stuff or 5G stuff, right? You want to talk about that next contract you had?
Yeah, I got to work with our former colleague Dana. Dana's a really good dude. Got to work with his company for a minute, doing like 5G, 4G concealments on street poles. So, like, you know, it's one of those things where you wouldn't even notice it's there until you really look at it and you're like, why is that thing shaped like that? You know, it's because there's a 5G antenna inside of it. Yeah. But yeah, I got to work there for a while, and that was pretty fun. Kind of a different ball game, but at the same time, it was definitely a fun design aspect. So I was more on the design engineer aspect on that one. So kind of helping before it got to manufacturing to make sure that it was flushed out before someone got it, and then, you know, because that's kind of the thing too, is you want to go from design engineer right to the shop. You know what I mean? Like, you don't really want to have a whole lot of stuff, but you want to make sure that, you know, you don't want your vendor calling back and be like, hey, this doesn't make sense, or these parts aren't going to can't fold that way. You know, how do you weld this? You know, so yeah, flushing those things out way at the beginning is probably a huge aspect. So.
Well, and you get into like building supersonic aircraft that hasn't been around for a long time. You go to like 5G towers, a lot of those types of environments where you're designing and manufacturing, you're trying to come up with solutions for tomorrow's problems, right?
Yeah.
You have to fit 5 pounds of stuff in a 4-pound bag, right? And the key to that is like, let's say any tower you see on the street, right? Whether it's a light pole or anything else, those are going to be there 10, 15, 20 years. So when you're designing them, you have to put it in a modular environment to where the technology and the hardware that sits inside of it's going to change, right? Like it's not that long ago, 3G was the end all be all, and now we're at 5G ultra wideband. And all of that capability is based on the change in receivers and hardware and all those components. So it's not like I have to move 5 ton per hour of X. It's I have to design a pole that's going to be there for 5, 10, 15, 20 years, or design an airplane that's going to carry 80 to 100 people supersonic worldwide for the next 20 years. Like you're designing for an unknown future that doesn't exist yet. And it makes manufacturing a challenge, right?
I think that, it was one thing that I think we had dialed at Carl Schmidt was standardization. I think that's, live and die by standardization. Like that's, you know what I mean? Like if you can make things that are modular and fit together and all that kind of stuff, like you're already winning. You know what I mean?
Yeah. Well, and you bring up a good point. I know we're coming up to the end of the hour here, but you bring up a good point. So before Dana and Casey were part of Carl Schmidt, I was there first. And part of the task that I was hired for by Carl was to overhaul the manufacturing process. Well, first overhaul the engineering process, and then I inherited the manufacturing.
Out to the floor.
Yeah, I inherited the manufacturing process second. And so when I started, they had 8 engineers in there putting out 3 conveyors a month. Middle of a huge project. By the time Casey and Dana and everyone was there, and we changed and overhauled the process and how we did everything, a little bit of, as you mentioned, multi-bodies and weldments, we completely disassembled everything, looked at all the tools we had, and there was no boundary or limit on anything. And we came up with a process that allowed 3 engineers to do 5 conveyors a month. And then beyond that, by adding CNC technology and things like that, we could produce sections of a conveyor for things that weren't even sold yet, because everything was modular. So every conveyor was custom and unique, but we were only building about 2% that was unique. Everything else was the same. The frames were the same. The stands were the same.
That's where you get into an issue, is when you start doing so much custom. Or you're trying to mold around something that a customer wants and stuff. And I think that's where you get into a lot of problems too.
Yeah. And a lot of it too, I look at it and it makes me chuckle being on this side of the fence, back on the software side. I honestly, when I went to Carl Schmidt, I thought I was done with this side of the world, if I'm being honest. I thought I was going to be in manufacturing. I sucked back in. But software is a tool just like a screwdriver. And we get in these perceptions of, I got trained a specific way, so that's the only way it works. Where I think what we did was a little unique, that I think, now bled over into what you and Dana and everybody else does, is we really looked at the software and it was like, look, there's no preconceived idea of how it should be.
Yeah.
Let's make it fit for what we need to do. And I think that was a little bit of our secret sauce.
Yeah. Looking at the conveyors and stuff, like you started looking at like holistically, like how does this get made? You know what I mean? Like, and we would take a section of conveyor and that would be a part. It wouldn't be an assembly. That would just be a part. Yep. And I feel like, and then that also bled into the drawings and the prints and everything, where it kind of just made it to where it's like, just focus on this and make this one section and check these numbers when you're done and you're over it. You know what I mean? Like, and I think that was something that was nice, was just looking at it like as how someone would build it, and I think that's the key of having that divide between manufacturing and design, like where you don't need to have a wall there. You know what I mean? Like, and it makes it so much easier to have that communication back and forth.
Well, and we took it a step further, where when we designed those things, we designed them based on the laser size that we had. So we knew exactly for a 10-foot section how many sheets of material were needed. So if we were going to quote lead time, we could go out, look at the rack, see the material that's there, and we knew how much material we had in stock versus how much we needed to order to fulfill that need. And we went from like being able to ship a conveyor in 16 weeks to be able to sometimes do it in 6. And it was all based on everything that we designed was built for, it took 3 sheets to do a 10-foot, 60-inch wide bed.
Yeah.
So we knew that 3 sheets was going to take us X amount of time, and then it went over to CNC to be bent, and then we just welded it.
Yeah, and that's kind of the whole thing we were talking about, the revolution that had to be on the truck. And, there's design, frameworks and things you have to do. And I think that, when you put yourself in the position of like, okay, I have to figure this out and it has to be on this sheet. Like that's, that's one thing. And I think that there is an idea where it's like, well, just cut it and do scrap, and you know what I mean? Like just do it, if you can't make it on the sheet, whatever. And it's like, well, no, that's the secret sauce is dialing the design down and figuring out how to fit it on certain parameters. You know what I mean? So yeah.
Yeah, because machine uptime is faster than a human moving material.
Yes.
And that's a lot of what we did. And we standardized like the legs. All the adjusters were the same. So you could swap between different conveyors, have the same adjusters. So if we had a slow time, you could have people just build legs that were in stock, right? Yeah. And then we got an order.
We need some legs. Yeah.
Yeah. You just paint it whatever color that customer wanted that was unique, and away you go.
Yeah.
I think that's part of what I've seen some of the struggle is with this transition is people look at the tools that they invested in, they got trained upon them once upon a time, and then they live and die by that rule on how they were trained because that's the only way it works. And I think with the power of technology and software today, you really sort of have to look at it as I have a problem that's X.
Yeah.
Can I use this tool to solve it? I don't care what the name on the box is. I don't care what anything that I was trained on how it works. Can I use it to solve this problem? And if so, then it has value.
Yeah. Yeah. And then, and that's kind of the whole thing too. There's so many ways to skin a cat with so many different, you know what I mean? Like, so it's one shop can do it this way and one shop can do it another way. But I think also communicating between other shops and other manufacturing facilities. I think there is like a competition when it comes to some manufacturing facilities where it's like we don't talk about what they do and we don't talk, you know what I mean? Like, but if you're homies with guy and you're hanging out and having beers, like, you can learn what they're doing and maybe that works for us. You know what I mean? Like it's all about the collaboration on stuff. You know what I mean? Getting the smartest people in the room to talk about something and drive towards something is the best way to do it.
Yeah. Well, and if you remember, your paycheck all comes from the same place, and you're all trying to get to the same point. That helps a lot of times, right?
Yeah, they may not be the same paychecks, but
very rarely are they the same paychecks. But they come from the same company, which means that your goals should align for that.
Yeah.
And I think what a lot of people get stuck in, and I know that in rural areas it's not as easy as bigger cities, but if your views don't align with that company, go find another company where your views align with that. I hate to tell people just go change jobs, but the reality is the world of manufacturing is changing at such a rapid pace that there's a spot for everybody.
Yeah. And I think too, if you're willing to learn and to make mistakes and to, better yourself, like there's a ton of opportunity that you can throw yourself into there too,
Yeah. Being open to learning is key. Just being a jerk about my way's the right way does not help with that.
Yeah, that'll go for a while and then it doesn't work, so.
We have a couple more comments and then, we'll wrap this up, but Judy posted CAD doesn't design for you. Know your company's production capabilities and toolings. It differs with each company.
Yeah.
Very true.
Very true.
And then John's been around a long time. You see him at 3D Experience World all the time. His comment was peer-to-peer learning is the best.
Yeah.
And I agree with that.
Yeah, when you get to learn with someone that they do it daily, you know what I mean, and you get to watch their workflow and how things go, and and then I think also too, what you're talking about with like finding another job, like projects can be cool, but it's really about who you work with. In my opinion, you know what I mean? Like, I think, you can have a cool project that's really, really fun and not have the best team. I haven't had that situation. I've been pretty lucky to work with really, really cool people and very talented people. But if I was going to choose over project or people I work with, it'd definitely be the people,
Yeah, I can tell you, over my course of my life, I've worked with some tough which ultimately is why I'm not there anymore. And maybe some of it could have been my personality didn't mesh with others. I have no blame of anyone else. It's just a matter of, sometimes a fit is not a good fit, right? People aren't all on the same journey in life, and it's important to find the people that you're going to go on that journey with.
Yeah.
You
That, and
know,
also you can rally up and we're gonna, we're gonna take this hill. We're gonna, you know what I mean? Like this project is gonna get done, and we got to get it done, And
yeah,
like I was saying, getting the smartest people in the room and brainstorming is the best way to do that.
yeah. I mean, in our Carl Schmidt days, I mean, I learned a lot from you on welding and fabrication and things like that. Um, you know, I learned a lot more about painting because I spent several days painting in the booth myself because we didn't have
Yeah.
people there to paint.
Yeah.
There's that big ramp thing that we sent to Alaska that time.
Oh yeah.
Remember that big bad boy?
There was there was so many weird projects at Carl
Yeah.
Schmidt that you kind of forget, you know what I mean? Like you think we
Yeah.
did, just conveyors, but it was like there was some weird stuff, you know what I mean?
Yeah. So for everyone watching, and this is one that will stick with me, I went to Alaska and spent a week in Wasilla doing recycling, but we built another one. So as cruise ships come to port, what nobody thinks about is all the garbage that gets offloaded from a cruise ship. It is staggering how much garbage comes off a cruise ship.
Yeah.
But all that garbage has to go somewhere to be processed. So in Alaska, we actually did a conveyor that went to a baler, but the way that the cruise ship offloads required this huge ramp. It was like 16-foot wide, 5 or 6 feet tall, and these trucks would back up it. But it's in Alaska, so we had to put some things in place to where the trucks wouldn't slide off the ramp, cause more problems. But the idea of it is all the garbage would then go into a conveyor and go into a baler, and then they would ship those bales by barge down to be sorted somewhere else.
Yeah.
So we built this monster ramp. It was insanely large, but in that there's its own challenges, right? Because it's got to break down to go on a barge to get to Alaska as well.
Yeah.
And how are you going to handle the sea salt? How are you going to handle those types of things from a normal painting scenario?
Well, it's interesting when you start realize or start thinking like, well, a truck can only fit like 13 feet or something. You know what I mean?
Yep.
Like
13,
there's limitations
6.
there. You know what I mean? You do not want to pay for oversized. Mean, that could break a project right there.
Yeah. So with that, we're getting to the end. So Casey, you're in the process now of looking for some other contract options. So Ian's going to put your LinkedIn profile in there. If anyone wants to reach out and chat with Casey about things and follow with him, please do. Yeah, we have 3D Experience World coming up with call for papers. It's 3dexperienceworld.com. Thanks, Ian, for putting that in the notes. I'm not the best at remembering things. I probably got hit on the head too much as a kid, and then the last thing is please subscribe to our channel and like it. And if you want to see other things on this coming up, please put it in the comments, put it in the notes, reach out to us. If you want to have Casey back on to talk a little bit more about some of his in-depth stuff, please reach out. So with that, Casey, can't thank you enough, man. I know, with a young child, there's a lot of things going on these days, and I appreciate you jumping on to chat with us. And
no problem.
Please come to 3D Experience World and see Casey. He's going to be there.
Yeah. I look forward to seeing you guys.
Thanks, man.
Yeah. Take it easy.
Sweet. Thanks for being on, man. I appreciate it. That went well.
No problem, dude. Yeah. Went way faster than I thought.